Alkali metals. As we have learnt, elements in the periodic table are classified into groups and periods according to the number of valence electrons and the number of occupied energy levels. Elements in the same group are said to belong to the same chemical family. The elements in Group 1 of the periodic table are called alkali metals. These include lithium, sodium, potassium, rubidium, cesium and francium. The electron arrangements, atomic radius, and ionic radius of the first three alkali metals are as shown. Each alkali metal atom has one electron in the outermost energy level. Down the group, there is an increase in the number of occupied energy levels. Atomic radius is the distance between the center of the nucleus of an atom and the outermost energy level, occupied by an electron or electrons. The atomic radii and ionic radii of the alkali metals increase down the group. This is because each alkali metal has one more occupied energy level than the preceding member in the group. Lithium has two energy levels. Sodium has three energy levels, while potassium has four energy levels. The outermost electron in a sodium atom is therefore further from the nucleus than the outermost electron in a lithium atom. This explains why atomic radii of the alkali metals increase down the group. When an atom loses an electron to form a positively charged ion, the remaining electrons experience greater nuclear attraction. The remaining energy levels move closer to the nucleus, resulting in a reduction in the radius. An alkali metal forms an ion by losing the single electron from the outermost energy level. The resulting ion, cation, has one occupied energy level less than the corresponding atom. Hence the ionic radius of an alkali metal is less than its atomic radius. Physical properties of alkali metals. To understand the properties of alkali metals, let us look at the physical properties of the first three alkali metals. Physical properties of lithium. Lithium is a silvery white soft metal that is easily cut. It has a melting point of 180 degrees Celsius and a boiling point of 1330 degrees Celsius. It is a good conductor of electricity. Physical properties of sodium. Sodium is a shiny gray soft metal that is easily cut. It has a melting point of 98 degrees Celsius and a boiling point of 890 degrees Celsius. It is a good conductor of electricity. Physical properties of potassium. Potassium is a shiny gray soft metal that is easily cut. It has a melting point of 64 degrees Celsius and a boiling point of 774 degrees Celsius. It is a good conductor of electricity. Alkali metals generally have a shiny metallic luster when freshly cut. However, the surface quickly tarnishes because of reacting with air. Alkali metals are soft and easy to cut. The softness and ease to cut increases down the group. This is due to the decrease in the strength of the forces holding the atoms together as you move down the group. Alkali metals have relatively low melting and boiling points. The melting and boiling points decrease down the group. This is due to the weakening of the forces holding the atoms together. The strength of the forces holding atoms together depends on the size of the atoms. The larger the atoms, the weaker the force. Thus, as the atomic radius increases, the forces of attraction between the atoms weaken, hence the decrease in the melting and boiling points down the group. Alkali metals are good conductors of heat and electricity. Conductivity in metals is due to the presence of delocalized electrons in the structure of the metal. Since they all have one electron in their outermost energy level, their conductivity is similar. Ionization energy is the minimum energy required to remove an electron from the outermost energy level of an atom in the gaseous state. Down the group from lithium to potassium, the first ionization energy decreases. This means that less energy is needed to remove the electron from the outermost energy level of a potassium atom than a sodium atom and a lithium atom. This is because the effective force of attraction on the outermost electron by the positive nucleus decreases with increasing atomic size and distance from the nucleus. In metals, the electrons in the outermost energy level move randomly throughout the metallic structure. Since the electrons do not remain in one fixed position, they are said to be delocalized. Chemical properties of alkali metals. Lithium. Sodium and potassium react vigorously with both air and water. Potassium is the most reactive and lithium is the least reactive. Reaction of alkali metals with air. When sodium is exposed, it reacts with moisture in the air to form sodium hydroxide. The sodium hydroxide further reacts with carbon for oxide in the air to form sodium carbonate. Sodium burns in air with a yellow flame to form a yellow-white solid, which is mainly sodium oxide. When sodium burns in air enriched with oxygen, it forms sodium peroxide. Potassium burns in air with a lilac flame to form a white solid, which is potassium oxide. Reaction of alkali metals with water. Lithium floats and reacts vigorously on water. A colorless gas is produced. The gas does not ignite spontaneously. The resulting solution turns red litmus paper blue. Sodium metal darts on the water surface as it melts into a silvery ball. A hissing sound is produced. A colorless gas is produced which may ignite spontaneously. The solution formed is alkaline. Potassium metal darts about on the surface of the water and melts into a silvery ball. A colorless gas is produced which spontaneously bursts into a flame. Potassium vapor burns with a lilac flame. The resulting solution is alkaline. From the observations, it can be deduced that potassium is the most reactive alkali metal. This is because the electron in the outermost energy level is loosely held by the nucleus and is easily removed during a reaction. The ease of losing valence electrons increases down the group as the atomic radius increases. Hence the increase in reactivity from lithium to potassium. Reaction of alkali metals with chlorine. When hot sodium metal is lowered into chlorine gas, the metal bursts into flame. White fumes of sodium chloride are formed. Lithium reacts less vigorously with chlorine to form lithium chloride. Potassium reacts much more violently with chlorine than sodium. Alkali metals react with chlorine gas to form the corresponding metal chlorides. The reactivity of alkali metals with chlorine increases down the group. This is because of the increase in atomic radius, which leads to increasing ease to lose the electron in the outermost energy level. Alkali metals react by losing the one electron from their outermost energy level to attain a stable electron configuration. Similarity of ions and formulae of some compounds of alkali metals. Each alkali metal ion combines with a single hydroxide ion to form the respective hydroxide metal, namely lithium hydroxide, sodium hydroxide, potassium hydroxide. This is because the valency of group 1 elements is 1. Each alkali metal ion combines with a chloride ion to form the respective chloride metal, namely lithium chloride, sodium chloride, potassium chloride. Two alkali metal ions combine with one oxide ion to form the corresponding oxide, namely lithium oxide, sodium oxide, potassium oxide. This is because the valency of oxygen is 2. Therefore, one oxygen ion requires two alkali metal ions to combine with, to form the corresponding oxide. Due to their high reactivity, alkali metals are not found as free elements. They are normally found in the combined state in the Earth's crust. Uses of alkali metals and their compounds. Sodium is used in the manufacture of sodium cyanide for use in the extraction of gold. Lithium is used in the manufacture of special high-strength glasses and ceramics. Lithium compounds are used in the manufacture of dry cells for use in mobile phones, laptops, stopwatches and electric vehicles. A molten mixture of sodium and potassium is used as a coolant in nuclear reactors. Sodium vapor is used to produce the yellow glow in streetlights. Sodium chloride is used as a food additive. Molten sodium is used as a reducing agent in the extraction of titanium from titanium perchloride. A mixture of sodium hydroxide, caustic soda, and carbon disulfide is used in the manufacture of artificial silk called rayon. Potassium is a vital nutrient for plant growth, and potassium-containing compounds like potassium chloride and potassium sulfate are used extensively in manufacture of fertilizers. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.